Today we're learning about sets and set notation. A set is just a group of items that have something in common. So for example, the set of people studying GCSE art or the set of animals that have 4 legs. In maths, the sets that you're most likely to come across will probably be sets of numbers, but that's not necessarily the case. Examples would be the set of prime numbers or the set of square numbers. We give sets names and we use capital letters for this. There are some predefined sets, such as n, the set of natural numbers. If you haven't heard that term before, natural numbers are just the numbers 1, 2, 3, 4, etc., the numbers we use for counting. Can you see that I've listed the numbers of the set in curly brackets or braces, as they're sometimes called? This is a standard way of listing the members of a set. Also note the language I've used. Items in a set are called members of the set. Another predefined set is Z, a set of integers or whole numbers. Now we can define our own sets and give them names. So I might decide that A is the set containing the numbers 1 to 5, and I would write A equals 1, 2, 3, 4, 5. And I could decide that B is the set containing the numbers 2, 4, 6, 8 and 10. Now thinking of the number 3, we can see that 3 is a member of A, but it's not a member of B. The notation we use to write this is 3 is a member of A. 3 is not a member of B. So the sign for is a member of is this, a sort of rounded E. Let's introduce some other terms you need to know. The intersection of two sets, written like this, means things that are in both of the sets. So in our example, A intersection B is 2 and 4, because 2 appears in both A and B, and 4 appears in both A and B. The union of two sets, written like this, means everything that's in either of the two sets. So A union B is 1, 2, 3, 4, 5, 6, 8 and 10. So everything that's in both those sets. So there are a couple more things that you need to know about sets. The universal set, represented by a curly E, like this, contains everything that we're interested in at the moment. So let's say A is the set containing all the students doing GCSE art, and C is the set containing students doing GCSE computing. Our universal set in this case might be all GCSE students at the school. So the universal set varies depending on the situation, and it'll be defined for any particular question. Another important set is the empty set, written like this, and I think that's fairly self-explanatory. It's the set that contains nothing. Finally, the complement of a set is everything that's not in that set, and we use a little dash to represent this. So the complement of set A would be written A dash. Going back to our earlier example where A was 1, 2, 3, 4 and 5, and B was 2, 4, 6, 8 and 10. Let's define the universal set as numbers between 1 and 10. The complement of A is just all those numbers from the universal set that aren't in A. So A complement is 6, 7, 8, 9 and 10. B complement would be 1, 3, 5, 7 and 9. So let's finish off by looking at an exam question. Here we're told that A is prime numbers between 10 and 16, and B is multiples of 3 between 10 and 16. So I would start by listing the members of each of those sets. So for A, we've got 11 and 13, that's it. For B, we'll have 12 and 15. So the first part says list the members of A union B. Now remember, that means everything that appears in both of the sets. So we'll have 11, 12, 13 and 15. Next part says what is A intersection B. Now looking at those two sets, there are no members that appear in both of them. So A intersection B is actually the empty set, so we'll just write the empty set symbol there. Is it true that 11 is a member of B? Well, looking at the list, no it's not, so the answer to that's no. Explain your answer. Well, B is multiples of 3 between 10 and 16. 11 isn't a multiple of 3, so it's not a member of that set.